So, won't have a very long session today. What I'm going to discuss today is radiation pressure. That means when an electromagnetic wave strikes a surface, what force does it exert on that surface? Right? Why should it at all exert a force? And how much force will it exert in different conditions? And therefore, what is the pressure that it will exert on the surface, which is radiation pressure? So, one thing, if this is a surface of area A, first of all, why should an electromagnetic wave at all exert a force? Why should it? Okay. Realize that the electromagnetic wave comprises of photons. If it's part of an electromagnetic wave of frequency nu, then the energy of the photon is h nu, right? Which can, if m is the equivalent mass of the photon, it can also be written as mc squared, which is like m into c, which is equivalent mass of photon into the velocity of photon, which is velocity of light into c, which is like linear momentum of the photon into c. P is the linear momentum of the momentum of the photon. That is h nu, which is like hc by lambda is pc, or the linear momentum of a photon is h by lambda, where lambda is the wavelength of the wave, right? Now, so if I can conceive of a momentum and an equivalent mass of a photon, there is matter-like behavior of a photon, then when matter-like behavior is there and it strikes a surface, why would it not exert a force on the surface? Now, when a photon strikes the surface, say there is a photon of linear momentum h by lambda. Let's say it strikes a surface normally. What are the two possibilities for that photon? Either it could get absorbed by the surface, right? Either it gets absorbed by the surface, or the photon could get reflected by the surface with an equal and opposite linear momentum. These are the two possibilities, right? When it gets absorbed by the surface, then the change in linear momentum of the photon is h by lambda, because when it is absorbed by the surface, it's as if the photon is gone, as if the linear momentum has vanished. As if the photon has gone and as if this linear momentum has vanished. So there is change in linear momentum of the photon, which is h by lambda, minus linear momentum here is 0 when it's absorbed, right? So the change in linear momentum would be h by lambda, not mu, h by lambda. H by lambda would be the change in linear momentum of the photon.
Yes, sir.
Right? तो सोचो एक पार्टिकल आ रहा है और वो रेस्ट पर हो जा रहा है, मतलब there is a force that the momentum, there is a force that the photon will exert on the surface, and therefore there is a force that the surface will exert on the photon, right?
Yes, sir.
Yes, sir.
Right? Which will depend on the change in linear momentum. In this case, suppose this happens, reflected, then very clearly there is an upward change in linear momentum. Final upward linear momentum minus initial upward linear momentum is minus h by lambda. So which is like a 2h by lambda. That's a change in linear momentum in the photon. Yes or no?
Yes,
So if it's absorbed by the surface, the change in linear momentum of the photon is h by lambda, and otherwise the change in linear momentum is 2h by lambda upwards. That means the surface exerts an upward force on the photon will exert a downward force on the surface, right?
yes, sir.
Yes.
Now, Can I wipe this off?
Yes, sir.
Yes, sir.
In general, every surface has a property which is like absorptivity, A, and reflectivity, R. Absorptivity refers to the fraction of incident energy absorbed, fraction of incident energy absorbed, the electromagnetic radiation that is striking the surface has a certain amount of energy. The fraction that is absorbed is absorptivity, which is obviously energy absorbed divided by total energy incident. Reflectivity R is about fraction of incident energy reflected. That's about the fraction of incident energy reflected, which is like energy reflected, which is proportional to the number of photons reflected by total incident energy. Obviously, दोनों fractions है. Suppose A is 1/3, R would be 2/3. Suppose A is 0.5, R would be 0.5. In all cases, absorptivity plus reflectivity would be 1. Either a photon will be absorbed or it will be reflected. Fraction is going to be 1. Right? So absorptivity is very clearly 1 minus reflectivity. Absorptivity is clearly 1 minus reflectivity. Right?
Yes, sir.
All good?
Yes, sir.
Now, obviously, when it's absorbed, the change in linear momentum of a photon is p by lambda. When reflected, the change in linear momentum is 2h by lambda. H by lambda and 2h by lambda. Right?
Yes, sir.
Yes, sir.
Now, let me look at, let's say, there is an incident beam of intensity I. I is like measured in watts per meter squared. Energy per unit time per unit area. Energy incident. But this area has to be normal to the beam. That area has to be, that is per meter square of area perpendicular to the beam. Right? It's joules per second per meter squared, but that meter squared is perpendicular to the beam. Is perpendicular to the beam. Right? That is intensity I and wavelength lambda. And wavelength lambda. Incident normally on a surface with area A. ये सरफेस है, इसका एरिया A है, इसका इंटेंसिटी I है, वेवलेंथ लैम्डा is का. Now I want to compute the force pressure on this area. Pressure is force acting perpendicular to the area divided by the area. Right?
Yes, sir.
Yes, sir.
Now two cases. Case one, say absorptivity is 1. That means reflectivity is 0. That means every photon that falls, this is a photon of linear momentum h by lambda. Every photon that falls is completely absorbed. That means change in linear momentum of a photon is going to be h by lambda. Photon absorbed. There is no reflection. Every photon falling gets absorbed. तो हर फोटोन का चेंज इन लीनियर मोमेंटम कितना होगा? h by lambda. Right?
Yes, sir.
Now, total incident energy. Total energy falling per second on the area is I into A. Right? I is what? Joules per second per meter square. That means this is if I multiply this with the area, I'll get joules per second. Energy falling per second on this.
Yes, sir.
Right?
Yes, sir.
That's the total energy falling per second. I into A. This is watts per meter squared into meter squared will give me joules per second into meter squared will give me joules per second. That means total energy falling on this area would be this joules per second per meter squared into meter squared will give me joules per second. Energy falling per second on this area.
Yes, sir.
अब इतना हर फोटोन का कितना एनर्जी था? Every photon has an energy which is hc by lambda. Energy of each photon h nu मतलब hc by lambda.
Yes, sir.
Total energy falling per second is this. अब इतना energy per second fall कर रहा है मतलब कितना photons fall कर रहा है? Divide by the energy per photon. So number of photons incident on the surface is energy incident per second on the surface per second. Number of photons incident per second would be energy incident per second divided by, this is total energy incident per second divided by energy per photon. है ना?
Yes, sir.
Total energy incident per second is I into A divided by energy per photon is hc by lambda. So this would be the number of photons per second. है ना?
Yes, sir.
और हर फोटोन का चेंज इन लीनियर मोमेंटम कितना है? h by lambda. This is change
Yes,
in linear momentum per photon. Per, right? Per photon. So total change in linear momentum change per second of incident photons is how much? एक फोटोन का एनर्जी चेंज h by lambda है, पर कितना फोटॉन्स गिर रहा है पर सेकंड? इतना फोटॉन्स गिर रहा है पर सेकंड.
Yes, sir.
So number of photons falling per second is ha by hc by lambda. And this is the total energy. This is the number of photons per second into change in linear momentum of a photon. This will be the total change in linear momentum per second of all photons incident. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
And total change in linear momentum of all photons per second is what? Force? Force acting on the photons?
Yes, sir.
Upwards,
Yes,
right?
sir.
And this must be force acting from Newton's second law, change in linear momentum per second. Change in linear momentum per second, yes or no?
Yes, sir.
Yes, sir.
So, if this is the force acting on the photons, then the photon up on the photons, the force acting is upward. So the photons will exert an equal and opposite downward force on the surface.
Yes, sir.
Yes, sir.
So force on the surface F would be h by lambda. Total change in linear momentum per second, Ia divided by hc by lambda. h कट जाएगा, lambda lambda कट जाएगा, which is Ia by c. Is the force acting on the surface,
Yes, sir.
right? And force acting, so radiation pressure is force per unit area F by A, which would be I by C. Agar absorptivity is 1, if absorptivity is 1. Yes or no?
Yes, sir.
স্যার নিচের পার্টটা দেখা যাচ্ছে না।
Force acting on the surface is total change in linear momentum per second of photons,
Yes, sir.
right? Which is F, which is h by lambda into Ia by hc by lambda. Agenista. This is
Yes,
the
sir.
total change in linear momentum per second. It must be the force. H and h cancels, lambda and lambda cancels. This is Ia by c. That's the force. So
Yes, sir.
force per unit area, which is radiation pressure, PR, that must be I by c. I is the intensity of the incident beam and c is the velocity of light. अगर absorptivity 1 है तो radiation और normal incidence है तो I by c हो जाएगा.
Yes, sir.
Yes, sir.
ठीक है.
Yes, sir.
Yes,
हाँ,
sir.
अब दूसरा केस लेते हैं. मिटा देंगे ना भाई तो सब.
हाँ,
Yes, sir.
Yes, sir.
Yes, sir.
Case 2. Absorptivity is 0, nothing is absorbed, reflectivity is 1. That means every photon gets reflected. Every photon will get reflected. Okay.
Yes, sir.
Yes, sir.
Again, incident beam I, intensity I. Area A. I obviously is watts per meter squared, which is like joules per second per meter squared of incident energy. Lambda is the wavelength, nu, which is c by lambda, etc. Same thing. I is the intensity of the wave. Or incident normally, normal incidence. Again, normal incidence. अच्छा. अब इसमें क्या है, हर फोटोन का every photon is falling down with a linear momentum h by lambda, right?
Yes, sir.
But it is getting reflected. It gets reflected with an upward linear momentum h by lambda. So in this case, what is the change in linear momentum of each photon?
2h by lambda.
2h by lambda. 2h by lambda is the change in linear momentum of each photon. Acha. Number of photons. What is the total incident energy falling? I into A watts.
Yes, sir.
Watts per meter squared into meter squared would give me watts. That means these many joules per second of incident energy.
Yes, sir.
इतना joules पर इतना joules में कितना photons आएगा? Divided by hc by lambda. These many photons. IA
Yes.
joules में कितना photons आएगा? IA by energy per photon. That will give me number of photons falling per second.
Yes,
Like
sir.
before.
Yes,
वापस
sir.
लिख नहीं रहे क्योंकि explain कर चुके हैं. This is right. Number of photons incident per second.
Yes, sir.
Per second into change in linear momentum of every photon. 2h by lambda.
Yes, sir.
So that's the total change in linear momentum per second.
Yes, sir.
Per second. So this must be the force on the beam, and therefore the beam must exert an equal and opposite force on the surface.
Yes, sir.
Yes, sir.
This must be a force
Yes, sir.
from second law. अब ये like before, F by A, as you can see, is 2I by C. This time the radiation pressure is 2I by C. This time the radiation pressure is 2I by C. Is 2I by C, twice the intensity divided by velocity of light. Yes or no?
Yes, sir.
Yes, sir.
पहले केस में क्या था? I by C, अब 2I by C.
Yes, sir.
Yes, sir.
So ये normal incidence. Now let me look at oblique incidence. So do you understand all of this? कोई issue नहीं है? Normal incidence में.
Yes, sir.
Yes, sir.
Now let me look at oblique incidence. ठीक है?
Yes, sir.
Okay.
एक मिनट, इस केस में ना पहले नॉर्मल इंसिडेंस में ना हमने पहले प्योर एब्जॉर्प्शन लिया, प्योर रिफ्लेक्शन लिया. अब लेते हैं कि कॉम्बिनेशन, सम फोटॉन्स आर गेटिंग एब्जॉर्ब्ड एंड सम फोटॉन्स आर गेटिंग रिफ्लेक्टेड. वो केस लेते हैं पहले. ठीक है, ओब्लिक के पहले. केस 3, एब्जॉर्प्टिविटी R is given. R पता है तो A पता है. R is given, reflectivity A which is 1 minus R, absorptivity. ठीक है? ये एक सरफेस है, इसमें some photons are getting absorbed, some are getting reflected. Right? I is the intensity, watts per meter squared, joules per second per meter squared of incident energy. This meter squared has to be, like I said, normal to the incident. Incident intensity is about watts falling on a unit area normal to the direction of the incident. Lambda है like before. अब देखो total energy incident कितना है? Energy per second. That means watts incident per second would be I into A. Watts. These many joules per second of incident energy.
Yes, sir.
ठीक है, इसमें how many photons are there? इतना IA joules में कितना photons होगा? hc by lambda. That means these many photons per second incident है. these many photons per second are incident, right?
Yes, sir.
Yes, sir.
IA by hc by lambda, these many photons incident per second. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
अब इसमें से कितना फ्रैक्शन एब्जॉर्ब होता है? A, है ना? कितना, how many photons get reflected? R, right? So number of photons absorbed, कितना फ्रैक्शन एब्जॉर्ब हो रहा है? ये टोटल नंबर ऑफ फोटॉन्स है, उसका कितना फ्रैक्शन एब्जॉर्ब हो रहा है? 1 माइनस r, राइट?
Yes, sir.
into A, which is 1 minus r, इतना एब्जॉर्ब हो रहा है per second. Number of photons absorbed per second. Number of photons reflected per second. कितना होगा? IA by hc by lambda into r. R is the fraction of the photons that are reflected. 1 minus r is the fraction of photons that are absorbed.
Yes, sir.
Total photons गिर रहा है per second. उसमें इतना 1 minus r fraction absorb हो रहा है, r fraction reflect हो रहा है, right?
Yes, sir.
Yes, sir.
Yes, sir.
Now, तो जो रिफ्लेक्ट हो रहा है फोटोन, फोर्स change in linear momentum of reflected photon of in momentum of absorbed photon. जो फोटोन h by lambda मोमेंटम से जा रहा है, वो एब्जॉर्ब हो जा रहा है, उसका चेंज इन लीनियर मोमेंटम कितना है? p by lambda, h by lambda, सॉरी, हर फोटोन का इतना चेंज इन लीनियर मोमेंटम हो रहा है.
Yes, sir.
तो these many photons per second, total change in linear momentum कितना होगा? This into h by lambda,
Yes.
change in total momentum per second of photons absorbed is क्या? एक फोटोन का h by lambda चेंज इन लीनियर मोमेंटम हो रहा है और इतना फोटॉन्स पर सेकंड, तो टोटल चेंज इन लीनियर मोमेंटम IA by hc by lambda into 1 minus r is the change in linear momentum per second, total change in linear momentum per second of photons absorbed. एक फोटोन का इतना चेंज इन लीनियर मोमेंटम हो रहा है और इतना photons per second गिर रहा है. That means this much is the total change in linear momentum per second because of absorption.
Yes, sir.
Right? Because of absorption, this is the total change in linear momentum. That means force because of absorption. Absorbed photons, FA, will be this, which is कितना? Which ये देखो, ये simplify करने से जैसे पहले आ रहा है IA by C into 1 minus r, है ना? ये नीचे का दिख नहीं रहा है शायद, है ना?
हाँ, sir.
ऊपर लिखते हैं. Force because of absorbed photons is IA by C into 1 minus r. FE, ये absorbed है, ठीक है? यहां तक ठीक है?
Yes, sir.
Yes, sir.
अब number of photons reflected कितना है? These many photons are reflected per second, right? These many photons are reflected per second. देखो,
Yes, sir.
these many photons are reflected per second. Change in linear momentum of reflected photon in momentum of each reflected photon कितना है? जो फोटोन रिफ्लेक्ट हो रहा है यहां से आ रहा है और जो
2h by lambda.
h by lambda से ऊपर जा रहा है h by lambda से गिर रहा है is 2h by lambda is the change in momentum of each reflected photon and the number of photons reflected are these many per second.
Yes, sir.
Yes, sir.
So total change in linear momentum per second due to reflection is एक रिफ्लेक्टेड फोटोन का इतना है पर सेकंड इतना फोटॉन्स रिफ्लेक्ट हो रहा है IA by HC by lambda into R. Yes or no? Which is
Yes, sir.
very clearly 2IA R by C. Right?
Yes, sir.
Yes, sir.
ये पोर्शन मिटा दे
Sir.
that means force due to reflection FR must be this into R, right?
Yes,
Yes,
sir.
Yes, sir.
sir. Yes, sir.
Total force कितना होता है? Force due to absorption plus force due to reflection. IA by C into 1 minus R plus 2IA by C into R. इसमें IA by C common ले लो into 1 plus 2R plus minus R 1 plus R is the force due to the entire thing. अब R का अलग अलग वैल्यू R equal to 0 डाल दोगे तो वो केस आ जाएगा पहले IA by C. R equal to 1 डालोगे total reflection you will get 2IA by C which you got. R का कोई और वैल्यू होगा 0.6 होगा तो 1.6 times IA by C. R will take values from 0 to 1. तो कोई भी केस के लिए ये फॉर्मूला याद रखोगे तो टोटल फोर्स आ जाएगा. तो रेडिएशन प्रेशर कितना होगा? F by A which is I by C into 1 plus R. That's the radiation pressure. अगर combination of reflection plus absorption होता है with reflection coefficient being R, reflectivity being R.
Yes, sir.
Okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now I'm going to take. So ये एक formula लगाने से all possibilities of normal incidence to compute the total force and radiation pressure can be obtained, है ना?
Yes, sir.
अब oblique incidence. What's a normal incidence था? Oblique incidence. उसमें case 1 say absorptivity is 1, reflectivity is 0. So I have a surface of area A. A is the area of the surface. एक बीम ऐसे इंसिडेंट है, पैरेलल बीम of intensity I watts per meter square, joules per second per meter square. अब ये इंसिडेंट एट एन एंगल थीटा हुआ, ठीक है ना? This is incident at an angle theta with angle of incidence theta. Angle of incidence इसमें theta है suppose. ये normal to the surface है. Now, I'm going to take absorptivity as 1. Absorptivity as 1 मतलब एक photon अगर ऐसे आ रहा है along this line at an angle theta, then his photon has a momentum p which is h by lambda, और वो absorb हो जा रहा है. उसका change in linear momentum कितना हो रहा है? h by lambda. Absorb हो जा रहा है, उसका change in linear momentum h by lambda है. पर जो surface है ना, वो force इस तरफ आ रहा है और 0 हो जा रहा है. मतलब the surface must have exerted a force like this.
Yes, sir.
In the direction of change in linear momentum is the force exerted by the surface on every photon.
Yes, sir.
Yes, sir.
अब ये देखो, इसमें let me first find out the number of photons incident per second. Number of photons incident per second निकालो. तो यार intensity है, ये meter square should be perpendicular to the surface ना.
Yes, sir.
I into A नहीं बोल सकते हैं, because this A is not normal to intensity.
Yes, sir.
Yes, sir.
तो क्या करोगे? You take a direction like this, ऐसा एक direction, which is perpendicular to, you take an area, ये area ऐसा लो, perpendicular to the direction of the beam. So this I, this meter square is about this area. अब ये area कितना है बेटा? ये थीटा है, तो ये 90 माइनस थीटा हुआ, ये 90 माइनस थीटा हुआ, ये 90 डिग्रीज है, तो ये थीटा हुआ. तो ये एरिया, ये ए है, तो ये एरिया कितना होगा? ए cos थीटा होगा. राइट?
Yes, sir.
Yes, sir.
अब इसमें टोटल इंसिडेंट एनर्जी जितना यहाँ पर होगा ना, वही एनर्जी तो फिर इवेंचुअली यहाँ फॉल करेगा.
Yes, sir.
Yes, sir.
इतना
Yes, sir.
एनर्जी, राइट? एनर्जी इंसिडेंट पर सेकंड is I into A cos theta, है ना? I is watts per meter squared into meter squared would give me joules per second. Watts और joules per second. एरिया से मल्टीप्लाई कर दिया तो joules per second आ गया. Right?
Yes, sir.
Energy incident per second is I into A cos theta. Right?
Yes, sir.
Yes, sir.
इतना एनर्जी गिर रहा है पर सेकंड. इतना एनर्जी में कितना फोटॉन्स होना चाहिए? सो
A divided by Q lambda.
number of photons per second would be energy incident per second divided by energy per photon, which is hc by lambda. Number of photons falling per second. ठीक है?
Yes, sir.
And change in linear momentum of every photon. Change in momentum of every photon. Is like you can see h by lambda. Right? Change in momentum of each photon is h by lambda. So total change in momentum of falling photons per second. ये नीचे का ये पार्ट दिख रहा है क्या?
Yes, sir.
Yes, sir.
Total change in momentum per second of all photons falling is what? Change in linear momentum एक photon का h by lambda into number of photons per second. hc by lambda. Right?
Yes, sir.
ये हो जाता है, ये हो जाता है I A cos theta by c। आइए cos theta by c हो जाता है, राइट। ये पोर्शन मिटा दे क्या,
Yes,
Yes,
sir.
sir.
ये वाला नीचे वाला?
Yes, sir.
Yes.
So this is the total change in linear momentum per second, right? So force F acting obliquely, ये force obliquely act करेगा, है ना, क्योंकि change in linear momentum इस direction में, यहां से आ रहा है जीरो हो जा रहा है, तो इस direction में वो force act किया है F, है ना,
हाँ
इस
सर।
direction में वो force act किया है, total force जो है ना इस डायरेक्शन में एक्ट किया, क्योंकि यहां है एब्जॉर्ब हो गया, टोटल चेंज इन लीनियर मोमेंटम जीरो हुआ, फोर्स एक्टिंग ओब्लिकली F is total change in linear momentum obliquely
Yes sir.
per second, ठीक है। पर तो ये तो टोटल फोर्स है और ये ओब्लिकली एक्ट कर रहा है, ये फोर्स जो है ना टोटल फोर्स ओब्लिकली एक्ट कर रहा है, क्योंकि चेंज इन लीनियर मोमेंटम भी ओब्लिक था, राइट।
Yes sir.
Yes, sir.
बट देखो ऐसे ये फोर्स एक्ट किया ऑन द फोटॉन्स, सो ऑब्वियसली जो फोर्स फोटॉन्स पे एक्ट कर रहा है सेम फोर्स सरफेस पर एक्ट कर रहा है, राइट। सो फ्रॉम न्यूटन्स थर्ड लॉ सेम फोर्स एक्ट्स ऑन द सरफेस। अब प्रेशर के लिए हम कौन सा फोर्स लेंगे?
F cos theta.
This force makes an angle theta with the vertical, right? This line, which is also the direction of the force, makes an angle theta with the vertical. This makes an angle theta with the vertical. So pressure के लिए कौन सा force लेते हैं? Pressure के लिए force लेते हैं acting normal to the area,
Yes sir.
right? So normal force acting on the area, acting on this area. ये तो oblique force हुआ, इसका ये component लेना होगा, F cos theta. Is F cos theta normal force Fn? Fn, which is F जो निकाला है IA by C cos theta into cos theta, so cos square theta, right? That's the normal force acting on this. मतलब इस surface पे ये जो है ये force normal force है that the photons are exerting. Therefore, the surface will exert on the photons an equal and opposite normal force Fn, right? So Fn is the normal force, but pressure क्या होगा? Pressure would be normal force per unit area. Fn by A. Fn by A is I by C cos square theta. That's the force, right?
Yes, sir.
Yes sir.
ये oblique incidence where absorptivity is 1, reflectivity is 0.
Yes, sir.
अब उल्टा लो, मिटा देंगे, absorptivity is 0, reflectivity is 1. That means all photons are getting completely reflected.
Yes sir.
Yes, sir.
Am I confusing you or are you okay with this?
Okay
Okay,
sir.
sir.
Okay, sir.
Sure?
Yes,
Yes,
sir.
sir.
Yes, sir.
So oblique incidence reflectivity is 1, absorptivity is 0. अब ये देखो सेम चीज करेंगे, इंसिडेंट बीम है, मेक्स एन एंगल थीटा, लैम्डा और आई है, ये जैसे कि ये एंगल थीटा है तो ये एंगल थीटा होगा, ये एरिया ए है, सो नॉर्मल एरिया नॉर्मल टू द बीम इज ए cos थीटा, राइट?
Yes sir.
अब देखो, this is I. What is the total energy falling like before? Total incident energy per second like before कितना है? IA cos theta is the energy
Yes, sir.
falling per second. Joules per second या watts? इसमें कितना photons होगा? Like before, number of photons per second. Per second कितना होगा? IA cos theta by HC by lambda. Right?
Yes, sir.
हर photon का, look at any photon, it's falling with a linear momentum h by lambda, making an angle theta like this, and is getting reflected with h by lambda, making an angle, following laws of reflection.
Yes, sir.
चला जा रहा है. अब ये देखो, जो photon fall कर रहा है ना, this is theta, this is theta. इसका vertical component of linear momentum है h by lambda cos theta, horizontal component है h by lambda sin theta, right?
Yes, sir.
जो reflect हो रहा है, h by lambda cos theta ऊपर चला जा रहा है और h by lambda sin theta नीचे आ जा रहा है, right? इसका components of linear momentum horizontally and vertically. So देखो horizontal direction में there is no change in linear momentum.
Yes, sir.
So the total change in linear momentum, as you can see, is h by lambda cos theta minus h by lambda cos theta. Which is like 2h by lambda cos theta is the total change in linear momentum of every photon.
Yes, sir.
And this is perpendicular to the surface. Already perpendicular to the surface है. So force भी perpendicular to the surface ही होगा. अगर change in linear momentum है perpendicular to the surface, force will also be perpendicular to the surface. Yes or no?
Yes, sir.
Yes, sir.
Right? So force acting would be total change in linear momentum है ना? एक फोटोन का linear momentum change कितना है? 2h by lambda cos theta. Perpendicular to the surface है, देखो, perpendicular. And number of photons falling per second इतना है. This is normal to the surface. IA cos theta by HC by lambda. Yes or no?
Yes, sir.
तो ये क्या हो गया? 2IA cos square theta by C.
Yes, sir.
It's a normal force.
Yes, sir.
So
Yes, sir.
pressure क्या हो जाएगा? Pressure हो जाएगा force by area. Force divided by area, तो 2I by C cos square theta हो जाएगा pressure.
Yes, sir.
कुछ नहीं हुआ, सेम रिजल्ट आया प्रेशर का, एक्सेप्ट ये फैक्टर 2 आ गया.
हाँ, sir.
Yes, sir.
Right?
Yes, sir.
इसको बस एक लास्ट केस कंसीडर करते हैं, फिर जनरल करते हैं. रिफ्लेक्टिविटी इज R इन जनरल, एब्जॉर्प्टिविटी इज 1 minus R. ठीक है, अब इतना लिखेंगे नहीं क्योंकि सारा चीज अब तुम लोग को अपने आप समझ में आने लगे. आई वोंट राइट सो मच. ठीक है, केस 3, रिफ्लेक्टिविटी इज R, एब्जॉर्प्टिविटी इज 1 minus R. ये इंसिडेंट है बीम, एरिया A लाइक बिफोर, ये थीटा, ये थीटा, और ये नॉर्मल डायरेक्शन है, A है, दिस इज थीटा, सो दिस इज A cos थीटा, A cos थीटा. वेरी क्लियरली टोटल एनर्जी फॉलिंग कितना है? टोटल एनर्जी फॉलिंग per second is IA cos theta, है ना? Total number of photons कैसे होगा? IA cos theta by energy per photon hc by lambda, है ना? Number of photons per second.
Yes, sir.
Yes, sir.
इसमें see number of absorbed photons. Absorbed photons कितना होगा? IA cos theta by hc by lambda into absorption coefficient, which is 1 minus r. इतना photons are absorbed per second.
Yes, sir.
हर फोटोन का जो एब्जॉर्ब हो रहा है, जो फोटोन यहां से आ रहा है h by lambda से, जो एब्जॉर्ब हो जा रहा है, उसका चेंज इन लीनियर मोमेंटम h by lambda है, राइट?
Yes, sir.
Yes, sir.
सो एब्जॉर्ब फोटोन के लिए फोर्स F1 है इन दिस डायरेक्शन.
Yes, sir.
Number of photons falling per second, and this is obviously along the oblique line. F1 is along the oblique line. Force due to absorption, right? Force due to reflection. Reflection में जैसे देखा है क्या हो रहा है? H by lambda cos theta was the vertical thing. Sin theta cancel हो जा रहा है, ऊपर h by lambda cos theta चला जा रहा है after reflection, right?
Yes, sir.
Total change in linear momentum जैसे दिखाया था 2h by lambda cos theta है. Therefore force अपने आप ही normal है F2, which is already normal.
Yes, sir.
F1 is along the F1 on the photons is along the oblique. F2 because of reflection on the photons is F2 normal. अलग-अलग direction में F1 F2
हाँ,
है
sir.
ना?
हाँ, sir.
Yes, sir.
So देखो total energy incident है IA cos theta divided by hc by lambda would be number of photons falling per second into reflection coefficient is the number of photons reflected per second
Yes, sir.
into change in linear momentum of every photon is the total change in linear momentum brought about because of reflection,
Yes, sir.
and this is along the normal, ये अपने आप ही normal में है, and this was
sir.
the force F2.
Yes, sir.
Yes or no?
Net force होगा F1 cos theta plus F2.
नहीं, net force वो नहीं होगा,
Net normal
net
force.
force normal. अच्छा, एक तो ये देखें ये कितना आता है, F1 आ जा रहा है तुम्हारा IA by C into 1 minus R cos theta आ जा रहा है, ये आ जा रहा है IA by C into R into cos square theta आ जा रहा है F2. ठीक है?
Yes, sir.
Net force would be the resultant of F1 and F2 जो कि हमको
हाँ,
पैरेललोग्राम लॉ से निकालना होगा,
हाँ, sir. ये net normal force होगा.
पर प्रेशर के लिए नॉर्मल फोर्स लेना होगा प्रेशर कैलकुलेट करने के लिए, है
Yes,
ना?
sir. हाँ, sir.
अब एक्चुअली क्या हो रहा है, ये फोर्स F1 तो ऐसे एक्ट कर रहा है एट एन एंगल थीटा और F2 ऐसे एक्ट कर रहा है परपेंडिकुलर. टोटल नॉर्मल फोर्स Fn would be F1 cos theta plus F2.
Yes, sir.
F1 cos theta is IA by C into 1 minus R cos square theta plus F2. F2 is IA by C into R into cos square theta. That's the total normal force. And force per unit area will be the pressure.
Sir, F2 में 2 का फैक्टर आएगा ना?
हाँ, ये 2 मिस कर गया क्या? ये 2 यहाँ आएगा, 2 यहाँ आएगा, 2 यहाँ आएगा, 2 यहाँ आएगा. ठीक है?
हाँ, sir.
So radiation pressure PR is Fn by A. Fn by A would be I by C cos square theta into 1 minus r plus 2r मतलब 1 plus r is the radiation pressure इस केस में। अब इसमें r का वैल्यू 0 डाल दोगे तो पहला केस एब्जॉर्प्टिविटी 1 आ जाएगा, r कैन बी 0 डाल दोगे r तो एब्जॉर्प्टिविटी 0 आ जाएगा, 1 आ जाएगा। You can plug in all values of r from 0 to 1 and get the radiation pressure for all cases here, right?
Yes, sir.
Yes, sir.
ठीक है,
हाँ
Yes,
सर।
Yes, sir.
चलो, this was all. This was one part that I wanted to cover. Recording stop कर दे बेटा।